But what we're going to do, we're going to cover our last, what was it, 13 questions, something like that. Now, this is going to be the toughest part of the test. It's going to be from 47 to 60. So we'll go through, I'll give you the answers, and then we'll go through the work, as much of them as possible. There's only about 2 in here that in terms of my work, I'm like, this one's a little tough to explain. So really, out of 60, if we come down to only really 2 that are pretty tough, and I think even one of those is an Algebra 2 question that I can show you where we can go back and look at some things for. So really, there's probably 1 on the list, and the only reason is because it's a later Algebra 3 lesson that I just don't remember well enough. Okay, so I apologize for that. All right, but 47 is B. 48 is G. 49 is A. 50 is F. 51 is E. 52 is H. 53 is B. 54 is K. Okay, anybody need any of that repeated, gone back through? Okay, all right. 55 is E. 56 is K. 57 is A. 58 is K. 59 is E, and 60 is J. Okay, so let's come back up to the top over here, starting with question 47. First column, 47 through 49. 58 was K. Okay, 47, 48, or 49? Okay, Dylan? 47, 49. Okay, anybody on 48? Nobody 48, just 47, 49. Okay, let's see, let's look at my work here. Only 10th, 11th, and 12th grade students attend Washington High School. The ratio of 10th graders to the school's total student population is 86 to 225. Okay, remember that we can rewrite that as 86 over 225. Okay, and the ratio of 11th graders to the school's total population is 18 to 51. If one student is chosen at random from the entire school, which grade is that student most likely to be in? All I did was I took those ratios and I found a decimal for them to find out kind of what their true number was. So 86 divided by 225 is 0.3811. And 18 over 51 is 0.35. So our question is which one of those groups is biggest? This is 10th grade, right? And this is 11th. Okay, so which one is bigger? 10th or 11th? 10th. So they're more likely. Wait. What did I do? Did I miss that? If the ratio of 10th graders to the school's total population is.
I thought that the 10th graders was like 0.34.
Maybe I did get that wrong. Let me look it up again. 86 divided by 225 is 0.38.
It says 86 to 255.
Oh, 255. That's probably where. 86 divided by 255. Yeah, 0.33.
Okay, but what happened to the other, like the 12th graders?
12th grade doesn't matter. Because all they are interested in, the ratio of 10th graders to the school's population, because it's to the total population. Okay, so the total population includes the 12th grade. So because this is bigger, the 11th grade, you're more likely to get somebody out of the 11th grade than you are the 10th grade. Okay? So it helps if I actually write numbers down correctly. Okay. Does that make a little bit more sense now? Okay. It's to me, it's a little like this. One thing that I was never good at as a kid was, if I was working in the shop building, of knowing which wrench I needed for like loosening which nut. You know what I mean? Is being able to associate a fraction in relation to an inch. Okay, so what typically does help in my brain is converting it to a decimal. So that's all I did, was just convert those to a decimal, see which one is bigger, and that's the one that's going to be more likely. So if you have a hard time imagining, well, which is bigger, 86 over 255, which none of us are probably going to know what that comes out to, right? And the same way, like if you had a wrench and it was an 1851st, you're not going to know that.
Hand me that.
Yeah.
5625 wrench.
Yeah, exactly. Okay, so 49 comes down. We've actually done this stuff before. We just haven't done it in terms of an inequality. Okay, we should know that what this is referring to is the equation of a circle, right? We've actually done equations of circles up to this point, right? Yes? No? I feel like we did. Equation of a circle is x minus h squared plus y minus k squared equals r squared, where h and k are the center of the circle. Maybe. It's been a while. Okay. Well, what they're saying here is that this is the equation of the circle. So what they're saying is that the radius is 3. The center of the circle is at 1, 2. So I'd go over 1 up 2. There's my center of the circle. Because this is shaded, what we are saying out of this is that we are less than the radius because we're shading what's inside the circle. Okay? If we were greater than the radius, okay, then we'd be shading everything outside the circle. Okay, which is why whenever we look at this, we're looking at something that matches this equation right here, where we're saying less than the radius, okay, which uses that same equation. Okay, does that kind of make some sense? So we at least understand the circle equation and that inequality. Basically, you're just matching the inequalities because they give you the equations of the lines. Now, on this, you just need to figure out, is y less than negative x plus 2, or is it greater than negative x plus 2? Well, because we're shading the bottom part of the line, y should be less than negative x plus 2. Okay, because we're shading underneath that line. Okay, which is why we get this equation, which is why A is the inequality that matches all of that information there. And they're both dotted, meaning that neither one of them was equal to. Okay, now there was several of you, how many of you had your hands raised for 49? Okay, did that clear it up at all for you? Okay, Dylan? Okay. So yeah, there's where you want to rehearse your equation of a circle if you don't remember that one. All right, let's see. There's several questions on this next column. Let's see. Let's look at 50, 51, 52. Anybody on any of those three? Okay.
51.
What's that?
50 and 51.
Okay. Anybody on 52? Nobody 52? Just 50 and 51. Okay. All right. This one on 50, I drew myself a small cubic picture. Okay. So I drew myself something that looked. If I can. Looked like that. Okay. It says you can find the volume of an irregularly shaped object by completely submerging it in water and calculating the volume the object displaces. You completely submerge a solid object in a rectangular tank that has a base of 40 centimeters by 30 centimeters. So I'm going to do 40 by 30. But it doesn't say how tall it is, which is really not too much of a problem. It's filled with water to a depth of 20 centimeters. So what I do know is that that's the depth of the water. Okay, you follow me so far? Okay. To a depth of 20 centimeters. The object sinks to the bottom and the water level goes up a quarter of a centimeter. Okay. So what you have to remember is that volume in a rectangular tank is length times width times height, right? So the length stays the same, the width stays the same, but it goes up 0.25. All right? So all we're doing is calculating volume. So in this case, volume is 40 centimeters by 30 centimeters by 0.25. That's all I have to do. And I think what you find whenever you calculate that is that you're going to get 300. Somebody run that out real quick for me. It comes out to 300. So that's the displacement because we're just looking at how much does it go up. Okay? So really that 20 didn't matter so much. It's just how much it went up. Okay? The long way of doing that would have been to find the volume of that and then find the volume of the new and then subtract the new, but you're going to get the same thing. You're going to get the 300, so there's really no need for it. Okay? Do we understand that? Okay, good. All right. Nobody on 51, correct? 51? 51? Okay. Maybe it wasn't, was there 52 in there too? Nobody was 52. Okay. All right. 51. This one, I ended up finding the answer. I'm just not, I don't know, I don't really like it. If x to y is 5 to 2, okay, so x over y equals 5 over 2, and y over z equals 3 over 2, what is the ratio of x to z? The way that it appears in here is you actually just take 5 halves times 3 halves, and it's going to give you 15 fourths. Because in a sense, the y's are going to cancel out, so to speak. I mean, you're going to be left with xz, which is 15 fourths. Okay? Like, it's kind of weird.
I thought it was 5 to 2 because it's x and equation.
Yeah, no, you multiply these. Okay. All right, let's see. Below that, because we didn't have 52, what about 54? 54, okay, 54, 54. You also need, oh, I'm sorry, skip 53. Okay. 53, the formula for the surface area of the rectangular solid shown below is area equals 2 times the length times the width, plus 2 times the length times the height, plus 2 times the width times the height. Essentially, there's a better formula for surface area. The better formula for surface area is perimeter of the base times the height. But in any case, let's see. Where L represents a length, W represents width, H represents height. By doubling each of the dimensions, length times width times height, the surface area will be multiplied by what factor? This, I actually, I didn't solve in a long, drawn-out way. One of the things I want you to realize whenever it comes to similar figures, all right, if I have a two-dimensional shape and I use a scale factor of 2, right, whatever scale factor I use, if I'm looking at what happens to the area, I'm going to end up taking the scale factor and squaring it, okay? Because when you think about area, it's units squared, okay? So if I took a scale factor and I want to know what's going to happen to the volume, I'm going to take the scale factor and cube it, okay? And the same with every new dimension. So if I double each of the dimensions in the surface area, what I'm going to end up doing is I'm going to take 2, because I'm doubling it, so times 2, and I'm going to square that. So the surface area is going to be taken out by, or is going to be taken up by a factor of 4. Okay, because I'm taking the 2 and I'm squaring it. So if I double the dimensions, the area is squared times the scale factor. So because the scale factor was 2, I just square that number. So if they'd said I'm going to increase, I'm going to triple each of the dimensions, then my area is going to increase by a factor of 9. You see what I'm saying? Okay. The other way to do that is that you could have given each of these a number. So let's say that you could have plugged in numbers, and if you make that, a rectangular solid could very easily have been a cube. So you could have made width 1, length 1, height 1, right? And then doubled all of those, and then saw the relationship, and you would have seen that the figure is going to have 4 times the surface area that it originally had. Okay? So you could do a test, but this was based upon something I knew would happen whenever you apply a scale factor and you look at what area happens. Okay, 54. A dog eats 7 cans of food in 3 days. At this rate, how many cans of food does the dog eat in 3+ days? This is a matter of distance, rate, and time, except in this case, we know our distance here is not distance. Our distance here is cans of dog food, all right, which is 7, and our time is 3 days, so my rate is 7/3. That makes sense? All right, so it says how many cans of dog food? Well, that's representing D, right? And D equals rate times time. So what I'm trying to solve for is new D, which should be, new rate times new time. Well, we're not changing the rate. Our rate is still 7/3, but we are changing the time. We're changing the time to 3 plus D. So I need to take 7/3 times 3, and then 7/3 times D. So what I'm going to get is, well, what's 7/3 times 3? Well, that's going to be 21/3, which reduces to just 7, right? Yes? Okay. So I get 7, and then 7/3 times D is 7D over 3. So that's, oh wait, hold on. Wrong one. I get that right there. Okay? So this is just a rate question. All right, back page. 55, 56, 57. 55, 56. Okay. All right, very good. All right. Yeah, 55. Were you 55? Okay, this one took me a little bit of time to put together. All right, Kelly asked 120 students questions about skiing. The results of the poll are shown on the table below. After completing the poll, Kelly wondered how many of the students polled had skied both cross-country and downhill. How many of the students polled indicated that they had skied cross-country, how many of the students polled indicated that they had skied both cross-country and downhill? Okay, so you have to understand first how this polling is being done. So we have 120 kids, correct? So everybody's going to answer the first question. All right, so if you add up 65 and 55, you're going to get 120 people. Okay, but 55 of those people say no, which means if you count up the number of people in the second question, it says if you've answered yes to question 1, which means none of these 55 people are going to answer question number 22. None of those 55 people are going to answer question number 1. All 65 are going to answer questions 2 and 3. We want to know the people that skied both, correct? Okay, so now we're looking at just the second question, okay? So of the 65 people, we're going to subtract these 37 people, okay? Because we want to know how many people skied both. So obviously we can't count the people. If you answered yes to question 1, did you ski downhill? If they said no, right, we don't want to count those. Obviously there's 28 people because 28 of them said yes, okay? Now in this last part, we don't want to include these 20 people who said that they didn't ski cross-country. So 28 minus 20 only leaves 8 people who could have skied both. Okay? That one took me a little bit of time to to piece together. Okay? Does that make some more sense? Yeah, that's a tricky question. One that can chew up quite a bit of time trying to visualize and see all that. All right. Question number 56. Who was 56? Okay. All right. We want to know what fraction of the square's area is in the region labeled A. So what I want you to understand is that each of these sections represents 1/3 of the area. Can we agree on that? Okay. So what I want you to understand here is that A plus B equals 1/3. All right, which means what I'm going to do is I'm going to divide 1/3 by 2, correct? Because A represents 1/2 of that 1/3. Okay, you follow me? Which is 1/6. Okay, here, A plus B plus C equals 1/3. What do I need to divide 1/3 by? By 3. Okay, because A only represents 1/3 of 1/3. Okay, which is what? Should be 1/9. Correct? All right. And then on this last one, this all represents 1/3, but A is only 1/4 of 1/3. So I'm going to take 1/3 and divide it by 1/4, which is going to be what? 1/12. And so then I want to add 1/6 plus 1/9 plus 1/12. Calculator's going to do that for me, and I'm going to get 13 over 36. Does that help you out? Okay. 57, this is one that we will cover later in Algebra 3, and I'm going to apologize for not being able to give you a strong answer on this. But what we're dealing with here is we're dealing with a sine function that has been shifted. So this is where we're going to get into phase shifts, but because it's all algebraic, it's a little bit tricky. What this is, this line that you see right here is the y equals sine x, because you'll notice that it crosses at the origin, it's going up positive. Okay, so that's my y equals sine x. This is my y equals sine times x plus a plus b for constants a and b are graphed. The functions have the same maximum value, which means they're peaking out at the same point. One of the following statements about the values of a and b is true. Which statement is it? It should be A. A is going to be less than 0, meaning that as we phase shift, it's actually going to be a fraction. And B is going to be equal to 0. And like I said, I can't do a good job of explaining the B equals 0 part of it at this point. I'll probably, just because when you teach 3 different math classes, you do tend to forget things even from year to year, and then you go back and review them and you remember certain things. But at this point, I can't give you a great answer on 57. I can tell you that the answer is A, but why it's not B, I'd have to look into some other lessons. Okay? So I apologize for that one. Okay, let's come up here. We're on our last couple. 58. Anybody issues on 58? Okay, good. This one is actually easier than you're probably making it out to be. Absolute values. What do we know about what absolute values have to equal always? All right. So is it possible for this to be less than -1? No, which is why it's going to be an empty set. And in case you're curious about that, we can go ahead and solve the rest of it, where we do x minus 5 is less than -1, and x minus 5 is greater than +1. Okay, well this would give me +5. We'd get an x is greater than 5. Up here we'd get x is less than 4, I want to say. What's that? Oh yeah, you're right. X is greater than 6, but x is less than 4. So you're seeing where that does show up there, but the fact that it can't be less than -1. It can't even be equal to -1 because absolute values don't work that way. Okay, but that's, I'm guessing that a bunch of you got J. Yeah, but you got to go back. You want to be very careful with absolute values and seeing that other side. Okay? All right, so that's why it was an empty set, K. All right, what about 59? Anybody 59? Okay. As part of a probability experiment, Elliot is to answer 4 multiple choice questions. For each question, there are 3 possible answers, only one of which is correct. If Elliot randomly and independently answers each question, what is the probability that he'll answer the 4 questions correctly? Probability is number desired over number total. So let's talk about the first question. How many correct answers are there on the first question? 1. How many total answers are available to him? No. 3. Okay, let's come to question number 2. Okay, did it change? There's still 1 right answer. There's still 3 possible answers. Okay, and what? There's 4 of these. So that's going to be 1 over 3 to the 4th. 3 to the 4th is 81, so you're going to get 1 over 81. He has a 1 in 81. He's got a 1 over 81 probability of getting all 4 of them right. Okay. Does it make sense? Okay. Just go back and remember probability. Number 60, this is one I'm guessing that a lot of us maybe had questions on. This one, you did cover this in Algebra 2. It was a part of Lesson 77. If I can go back and find it. They do give you 2 formulas. They give you the law of sines, and they give you the law of cosines. They give you 2 possible formulas. The problem with this is that law of sine is used to find the area of a triangle that's not a right triangle but given certain degrees and side lengths. Law of cosines is the one where if you have an included angle, okay, which of the following equations for the smallest triangle? So what I did is I drew it, okay, where I had 14, 18, and 20. Let's see, which of the following equations when solved for theta gives the measure of the smallest angle of the triangle? Okay, so I'd end up putting theta right there, right, because it's going to be opposite the smallest angle, okay? And that actually uses law of cosine. And they do give me law of cosine, okay? Then all I have to do is plug things back in, okay? In this case, you only have 2 options because law of sine is solving for area. We don't need area. We need to be able to find a missing angle, okay? So it's going to either be J or K. In our case, it's going to be J because we're going to use that for my C, okay? Where 18 and 20 are A and B, okay? So that's really just knowing those formulas and what they're used for, and then how we would put those things into that formula, okay? All right. And because we're trying to solve for angle theta, you know, and it's going to be opposite of 14, that's why we use J the way that we do. Okay, again, it was questions 60 and 57 were the ones that I felt pretty iffy on and being able to give you a direct answer, being able to give you a good, clear answer on, so I apologize for those. But I'm going to stop right there.